Today's video is on lattices, and now let us discuss about sublattice. A non-empty subset S of the main lattice L is called a sublattice of L if and only if S is closed under both the operations join and meet. That is, if A comma B belongs to S, then A join B and A meet B are also the elements of S. See here, a non-empty set S is non-empty and S is said to be a sublattice of this main lattice L if and only if S is closed under the operations join and meet. That is, if two elements exist in S, then A join B and A meet B are also the elements of the set S, then S is said to be a sublattice of the main lattice. And here is the problem related to this. See here, consider the lattice LR represented by the hash diagram shown below. L is given as 1, 2, 3, 4, 5, 6, 7, 8. And we have to check whether the following sets M1, 1, 2, 4, 6, M2, 3, 5, 7, 8 and M3, 1, 2, 4, 8 are the sublattices of this main lattice or not. See here, here is the hash diagram given. See, in M, 1 to 8 elements are there. I'll show you in the hash diagram. This is 1, 2, 3, 4, 5, 6, 7, 8. So according to this hash diagram, so we have to consider this M1, 1, 2, 4, 6 and we have to show whether it is a sublattice or not. See here, case 1. So given L is a lattice and R is a relation on L. See here, given L is equal to 1, 2, 3, 4, 5, 6, 7, 8. So this is the main lattice. And M1 is equal to 1, 2, 4, 6. So this is the subset of this main set L. And we have to show that this M1 is a sublattice or not. According to the hash diagram, we have 1, 2, 3, 4, 5, 6, 7, 8. So I have chosen only 4 elements here. And the hash diagram will be, here is 1. See here, 1. Here is 2 and again we need 4. So 4 is here and 6 is here. So this is the subset of L. So according to this lattice, we have to show whether it is a sublattice or not. So we have to prove that it is closed under the operations join and meet. See here, according to the table, so this is join and this is meet. And now let's move on. So join is nothing but the least upper bound and meet is nothing but the greatest lower bound. See here, so for 1 and 1, see here for 1 comma 1, so 1 is the upper bound. See here, upper bound. So for 1, 2, so 1 and 2, 2 is the upper bound. For 1 and 4, 4 is an upper bound, that is least upper bound. 1 and 6, see here for 1 and 6 is the upper bound. And see here for 2 and 1, for 2 and 1 again the upper bound is 2 and again for 2 and 2, so for 2 and 2, 2 is an upper bound and for 2, 4, see here for 2 and 4, 6 is the upper bound. See here, this is 6 and for 2 and 6, for 2 and 6, 6 is the upper bound. For 4 and 1, see 4 and 1, 4 is an upper bound and 4, 2, see here for 4 and 2, 6 is an upper bound. And see here for 4 and 4, again 4 is an upper bound and 4, 6. See here for 4 and 6, 6 is an upper bound. 6, 1, see here this is 6 and 1 and 6 will be the upper bound. For 6, 2, for 6 and 2, 6 is an upper bound and 6, 4, see here for 6 and 4, 6 is again the upper bound and for 6 and 6, 6 is an upper bound. And coming to the greatest lower bound here, meet, that is A meet B for 1 and 1. So for 1 meet 1. So this is the lower bound here. What is the lower bound? 1 will be the lower bound. For 1 and 2, what is the lower bound here? Again 1. For 1 and 4, 1 is the lower bound. For 1 and 6, 1 is the lower bound. And 2, 1, see here, 1, 2, 1, 1 is the lower bound. For 2 and 2, 2 is the lower bound. For 2 and 4, 1 is the lower bound. For 2 and 6, 2 is the lower bound. So 2 is the lower bound. For 4 and 1, see here for 4 and 1, 1 is the lower bound. For 4 and 2, 1 is a lower bound. For 4 and 4, 4 is a lower bound, and 4 and 6, 4 is a lower bound. And see here 6, 1. So 6 and 1, 1 is a lower bound. For 6 and 2, 2 is a lower bound. And 6 and 4, for 6 and 4, 4 is a lower bound. And 6 and 6, 6 is a lower bound. See here, if you observe, all the entries in the composition table are the elements of this M1, 1, 2, 4, 6. So between the operations join and meet, so M1 is closed under the operation join and meet. Therefore M1 is a sublattice of the main lattice L comma R. See here, see all the entries 1, 2, 4, 6, see 2, 6, everything are the elements of, every element is an element from the set M1. See here, from these two, 1, 2, 4 and 6, every element is from the set M1. Therefore A join meet and A meet B and A join B are all the elements are from the elements of M1. Therefore M1 is closed. Since all the entries in the table are the elements of M1, 1, 2, 4, 6, M1 is closed under the operation join and meet. Therefore M1 join meet is a sublattice of this main lattice L comma R. And see, this is case 1. And see, coming to the case 2 here. So what is case 2? L is a lattice and R is a relation on L. And see here, the main set L is given as 1, 2, 3, 4, 5, 6, 7, 8. And the subset here M2 is taken as 3, 5, 7, 8. This is the main hash diagram 1, 2, 3, 4, 5, 6, 7, 8. And see here, we need 3 here. So 3 is here. And next 5 here. So 5 is here. 7 is here and 8 is here. So this is the subset of the main set lattice L. See here, we have to show it is closed under the operations join and meet. So here is the composition tables. So here is the join. 3 join. So join is nothing but the least upper bound. So meet is nothing but the greatest lower bound. For 3 and 3, the upper bound is 3. For 3 and 5, see, for 3 and 5, the upper bound is 5. For 3, 7, see here, comparing 3 and 7, 7 is an upper bound. And see 3 and 8, for 3 and 8, 8 is an upper bound. 5, 3, see, for 5 and 3, 5 is an upper bound. 5 and 5, so for 5 and 5, 5 will be the upper bound. 5, 7, for 5 and 7, 8 is an upper bound. And next one 5, 8, 5 and 8, 8 is an upper bound. And see 7, 3, 7 and 3, 7 will be the upper bound. 7, 5, so this is 7 and 5, 8 is an upper bound. And next 7, 7, 7 will be the upper bound. And next one 7, 8, so this is 7 and 8 will be the upper bound. And 8, 3, so this is 8 and 3, the upper bound here is 8, the upper bound here is 8. For 8, 5, so 8 and 5, 8 is an upper bound. 8 and 7, for 8 and 7, 8 is an upper bound. 8 and 8, 8 is an upper bound. And next coming to meet here, for 3 and 3, so 3 is a lower bound. 5, 3, 5, for 3 and 5, 3 is a lower bound. For 3, 7, so 3 and 7, 3 is a lower bound. For 3 and 8, 3 is a lower bound. And see 5, 3, so this is 5 and 3 is a lower bound. For 5 and 5, 5 is a lower bound. 5, 7, so this is 5 and 7, 3 will be the lower bound. And 5, 8, see here, for 5 and 8, 5 is a lower bound. And see 7, 3, 7 and 3, 3 is a lower bound. 7, 5, see here, for 7 and 5, 7 and 5, 3 is a lower bound. For 7, 7, 7 is a lower bound. 7, 8, 7 is a lower bound. And next one 8, 3, so this is 8 and this is 3 and 3 is a lower bound. 8, 5, see for 8 and 5, 5 is a lower bound. 8, 7, see here, for 8 and 7, 7 is a lower bound. And 8, 8, so 8 is a lower bound. See, if you observe, all the entries in the table are 3, 5, 7, 8. So this is 3, 5, 7, 8. All the entries in the composition table are the elements of the set 3, 5, 7, 8, M2. Therefore, M2 is closed under the operations join and meet. So M2 satisfies the closure property. Since all the entries in the table are the elements of M2, that is 3, 5, 7, 8, M2 is closed under the operation join and meet. Hence, M2 join and meet is a sublattice of L and L, R. And next, coming to the case 3. So here is L is a lattice and R is a relation on L. L is equal to the main set 1, 2, 3, 4, 5, 6, 7, 8. So here if you observe, I have taken M3, the subset 1, 2, 4, 8. See here, this is the main hash diagram, that is 1, 2, 3, 4, 5, 6, 7, 8. Here 1 is needed, so I wrote 1 here. So here 2 is needed, 4 is needed, and there is 8 here. So there is 8 here. See here, again I have to show the closure property holds or not. So I am taking join and meet. So join and meet. For what is join here? Join is nothing but the least upper bound, and this is the greatest lower bound. See, coming to this point, 1, 1. For 1 and 1, the upper bound is 1. So for 1, 2. For 1, 2, what is an upper bound? 2 is an upper bound. For 1 and 4, 4 is an upper bound. And for 1 and 8, see here, for 1 and 8, 8 is an upper bound. And 2, 1, see here, for 2 and 1. So which one is an upper bound? 2 is an upper bound. And next, coming to which point? For 2 and 2. 2 and 2, 2 is an upper bound. For 2 and 4, see here, for 2 and 4, the upper bound is here 6. For 2 and 4, the upper bound is here 6. And for again 2 and 8, see here, for 2 and 8, 8 is an upper bound. So 8 is an upper bound. For 4, 1, see here, this is 4 and 1, and the upper bound here is 4. 4, 2, see here, this is 4 and 2, the upper bound here is 8. For 4 and 4, the upper bound is 4. 4, 8, so this is 4 and 8, the upper bound is 8. 8 and 1, so for 8 and 1, 8 is an upper bound. So for 4, 8 and 2, so there is 2 here and 8 is here, and 8 is an upper bound. For 8 and 4, 8 and 4, 8 is an upper bound. For 8 and 8, it is an upper bound. So coming to the meet here, see here, for 4 and 2, see, coming to this, 4 and 2, the upper bound is 6 here. So if you observe this one properly, so we have to consider this one, as there is a problem in connecting 8 with 2. See here, for 4 and 2 here, for 4 and 2, 6 is an upper bound. So here I have to write 6 here. See, here it is 6. And next 4 and 1. See, for 4 and 1, 4 is an upper bound. And see, coming to the meet, and again 1, 1. So 1, 1, it is 1. Least upper bound. So for 1 and 2, see here, 1 and 2, 1 is the least. And next 1 and 4, 1 is the least upper bound. Sorry, greatest lower bound. For 1 and 8, 1 and 8. So 1 is the lower bound. For 2 and 1, so this is 2 and 1. Again 1 is a lower bound. Again for 2 and 2, 2 is a lower bound. 2, 4. So for 2 and 4, what is the lower bound here? 1. For 2, 8. So this is 2 and 8. What is the lower bound here? So this is 2. For 4, 1. So this is 4 and 1. What is the lower bound here? 1. 4, 2. So 4 and 2, the lower bound is here 1. So 4 and 4, the lower bound is 4. 4, 8. So this is 4 and 8. The lower bound is 4. And next 8, 1. For 8 and 1. So what is the lower bound? 1 will be the lower bound. For 8 and 2, 2 will be the lower bound. For 8 and 4, 4 will be the lower bound. 8 and 8, again 8. So if you observe, there is a logic here. See here, all the entries in the table are 1, 2, 4, 6, 8. See here, this is 1, 2, 4, 8. So here 1, 2, 4, 8 is present and 6 doesn't belongs to the set M3. Therefore, M3 is not closed under the operation join and meet. Therefore, see here 4 join 2 is equal to 6, which doesn't belongs to M3. And next 4 join 2 is 6 and 2 join 4 is 6. So 6 doesn't belongs to the set M3. So there is no 6 in the set M3. Since A join B and A meet B should be the elements from the set, given set S. Therefore, S is said to be the sublattice of the main lattice L. So here 6 doesn't belongs to M3. Therefore, the least upper bound of 2, 4 doesn't exist. Therefore, M3 is not a sublattice of L. So case 1 is a lattice. So M1 is a lattice. See here, I'm showing here M1 is a sublattice, and next M2 is also a sublattice, whereas M3 is not a sublattice. And here is the problem. So this is also most important. If you understand, you can frame any type of question and you can easily get the solution if you follow these videos. And I'll be uploading many more videos related to this series. Until then, stay connected, and thank you so much for watching. If you really like, you know what to do, please subscribe to this channel and share it with your friends. Thank you so much.